So our first property is the product property, and it basically says that if we are multiplying two things with the same base, that we're going to end up keeping the base, and then we are going to add the exponents. So in this case, we added 7 plus 3 to get 10. So then on this one, our base in this problem is 7, so we're going to keep the 7. Then we're going to end up adding our two exponents, so that would be 8 plus 6, and we'll get 7 to the 14th as our final answer. All right. So then our next property was the quotient property. So the quotient property says that if we are dividing pairs with the same base, we're going to keep the base. So in this case, we're going to keep the 3. And then we're going to end up subtracting the exponents, but make sure you subtract them the top exponent first and then the bottom exponent. So that's where we got 6 from. So on this example, our base is 9. And then we're going to take our exponents and subtract, so this will be 13 minus 2, and we'll get 9 to the 11th. I also want to mention that this could be written as an older kind of division style instead of a fraction. And it means the same thing, just when you go to divide, you go from left to right, or when you go to subtract, you go from left to right. So the next property we talked about was the power property, and it says if I have something that already has an exponent on it and I'm taking it up to another exponent, then I'm going to end up multiplying these exponents and keeping the base. So in this first example, we have a base of 6, which we kept. Then we ended up multiplying 3 times 5 to get 15. If there are multiple bases and multiple exponents, you still treat it the same way. So we have a base of 5, so it's going to be a base of 5. We're going to multiply this outside exponent to every inside exponent. So 7 times 4 gives us 28. Then we have our base of 2. And then 4 times 5 gives us a new exponent of 20. So on this, we're going to end up multiplying 9 times 4, and we'll get 3 to the 36. Now on this one, it's a little tricky. I want you to look at this 6. There is an exponent on it, although it's imaginary. I can't see it. So remember, there's an imaginary 1 on this 6. So even if I don't see it, it is there. So we're still going to multiply our exponent to every inside exponent here. First base was 8, so we're going to keep the 8. Then 7 times the 8's exponent of 2 will give me 14. Then we have a base of 6. 7 times the 6's exponent of 1 will give me 7. So there are my final answers. All right, and then our last properties deal with the 0 and negative. So the 0 and the negative. So if we look at it, it basically says if it's negative, we are going to take the reciprocal and then make the exponent positive. So first thing is, if it's not already a fraction, we're going to make it a fraction, putting it over 1. Then we are going to take the reciprocal, which is basically a fancy word for flipping it. So we're going to flip this fraction, and then we're going to make the exponent positive. So when you take that reciprocal, when you do that flip, that's when the exponent becomes positive. All right, and then we look at this one right here, same thing. We got a negative exponent in the denominator. We are going to flip our fraction, which is taking the reciprocal, make our exponent positive. Now anything divided by 1 is just itself. So that's why we have 6 to the 5th over 1 is equal just to 6 to the 5th. Because anything divided by 1 is just itself. So if we look at this example right now, I could write it over 1 to make it a fraction. I'm going to take the reciprocal. And when I take the reciprocal, my exponent becomes positive. All right, so probably the easiest one on here is the 0 property, which says that all bases with an exponent of 0 will have a value of 1. So anything to the 0 power is equal to 1. If you have to do anything like multiply in this case, on this example, 0 times 3 will still give you an exponent of 0, and therefore it's equal to 1 overall. So anything to the 0 power is 1.